In this video, we're going to talk about 5.1 Objective 4, where we estimate areas and relative frequencies under the normal distribution. I'm going to be doing this using the empirical rule or the 68, 95, 99.7, 95, 99.7 rule is how your textbook refers to this. And these are percentages. And we'll be talking about this rule specifically in the next video, but I'm going to be using it this time to say that if something is normally distributed here, and here's the mean right here in the middle, that here's, let's just call this X bar, that if I go one standard deviation away to the right or to the left, I'll just put a 1 in there to be explicit, that between -1 and 1 standard deviation is this 68%, which means that there's 34% on either side when I cut that in half. And then between -2 and 2 standard deviations, here there's 95%, but we already used up 68% of that. So there's 27% left, meaning that there's 13.5% here and here. And that's between -2 standard deviations and +2 standard deviations. And then between -3 and 3 standard deviations, there's 99.7%. So 99.7 minus 95 is 4.7. So there's 2.35% here and here. And this is X bar minus 3 standard deviations, X bar plus 3 standard deviations. And then we just talk about these little pieces right here are the remaining 0.3%. So there's 0.15% here and 0.15% here. All right. Again, much more on that in the next video that we're going to make. But right now, I want you to see that the total area under the curve is 100% or 1.00. And in this case, they tell us that 69% is our mean. And our standard deviation is 4. And so I can write 65 as X bar minus 1s. And so the relative frequency or area probability represented here, the values that are less than this. So I want the 50% that's to the left of the graph minus the 34% that is between 0 and 1 standard deviation to the left is going to be 16%, which is this. And this rule is called an empirical rule, meaning that we've got these numbers strictly by observation and experimentation. We're going to learn other ways to do this with some tables and calculator and other things later that give us slightly different values in this, but these are good approximations. Estimate the relative frequency values greater than 65 inches. So greater than is going to be 1 minus this. If this is less than, then I want the complement of that. So 100 minus 16 is going to be 84%. Estimate the relative frequency between 65 and 69. So that's this area that's between the mean there. That's going to be 34%. And greater than 69, which is greater than that means, should be 50% of the data. All right. One more question here. Basically the same type of question, not going to draw the chart again here, but the standard deviation is 15, and they want us to figure out the mean here first. It appears to be right there. And so that is at 110, because each of these tick marks is 5. So X bar is 110. And then 95 is going to be X bar minus 1S. So this is really the same question as before. We just have different numbers, and they want you to see that if we do less than, so we have that 50% minus that 34% was that same 16% as before. And then if they say between 105 and 125, so now this is going to be something that I'm not going to get exactly from this rule, but I know what numbers it's going to be between. So 105 to 125, 125 is going to be exactly 1 standard deviation to the right. Right? And then we know that 95 was 1 standard deviation to the left, but it's a little bit more than just 34%, right? So 47% is reasonable here because this was 34%, and we need to add just a little bit more here because it was not just this area, but it went over there just a little bit to the left, but not all the way to make another 34%. So, and estimate the percentage of students whose blood pressure would be greater than 125. So again, 125 is 1 standard deviation to the right. This is similar to asking what percentage is to the left less than 1 standard deviation to the left. We should get the same percentage here because it's symmetric. And that's going to be it. So again, this was just estimation, and they meant for you to just look at it and take a good guess. But I wanted you to actually have this rule in mind to help you make better guesses. And we're going to talk specifically about this empirical rule, this 68, 95, 99.7 rule, when we come back next time and talk about 5.2 objective 1. So we'll see you for the next video.